For today's Algebra 1 video, we're going to look at sequences on a graph. So, as the warm-up that you have here, it says to find the pattern and how it is connected to the graph. What would be the sixth term look like? I want you to pause the video at this point, and I want you to actually challenge yourself and do the warm-up before I do it. I want you to count how many is in term 1, how many is in term 2, 3, 4, continue on all the way to 6, and see how many blocks there will be. Now that you've paused the video, now we're going to actually look at the pattern. Well, what we're going to do is we're going to count how many blocks there are in here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So at term 1, I have 13. For term 2, what I have is 1, 2, 3, 4, 5, 6, 7, 8, 10, and 11. I have 11. For term 3, you should have gotten 2, 4, 6, 8, 9. 2, 4, 6, 8. I'm sorry, 2, 4, 6, 7. So, as you can see that it is decreasing each time, but how much is it decreasing by each time? Well, it's decreasing by 2. So 13 to 11 is minus 2, 11 to 9 is minus 2, 9 to 7 is minus 2. If I continued on, term 5, 7, 6, 5, it would look something like this. There would be 5 blocks left, and at term 6, there would be 3 blocks left if I'm minus 2. Now you're questioning what the heck the graph is for? Well, if you noticed, these are actually the terms, and these are the number of blocks. As you can see, it's decreasing consistently by 2. So since it's subtracting, this is going to be an arithmetic method. So let's get started today with our lesson. So today's lesson, we're going to look at how many birds. I want you to actually pause this video and I want you to match up the graphs and the words. So I want you to read each of the little sentences below and I want you to match them up with the graph. Now remember, you can label the graph and anything like that. So go ahead, pause the video, and I want you to figure it out. Now that you've paused the video, here's what our answers are going to be. So for graph A, my answer is, or the little sentence that I have, or the sentence that matches with it, is going to be option number 3. A population that initially has 20 birds approximately doubles every 10 years. So if you notice that all of these actually say that all of our birds are starting with a number of 20. So I know that each of these are going to count by 20. So if I wanted to, I could honestly label the y-axis. Now, as you can see, the sentence is saying every 10 years it's going to double. So from 20 to this year is 40. Well, I know that every 10 years it doubles, so my x-axis must be counting by tens. And go ahead, if you wanted to label the graphs, you totally can, because it tells us that all of them initially start with 20 and something is happening to the birds. So B is going to actually match number 1, a population that initially has 20 birds approximately halves every 10 years. So if this is 20 birds, at 10 years, I should have 10 birds. Half of 10 would be 5, so at 20 years I'd have 5, and so on and so forth, till I have no more birds. And letter C is a population that initially has 20 birds. We always start with 20 and increases by 10 birds every year. So we can see that at 10 years, I'm going to have 10 more birds, so I'm going to have 30. At 20 years, I'm going to have 40, and so on and so forth. And letter D, you actually had to draw by yourself. It was the last option was left was a population that initially has 20 birds, approximately decreases by 10 every year. So instead of increasing by 10, it's decreasing. So the first year we're going to drop down to 10 birds, and then by year 20, I'm going to have no birds left, unfortunately. So this is a great way to match words and graphs together, because when we see patterns and sequences, we usually see them in graphs, we see them in numbers, anything like that, we can notice a pattern. We also want to be able to notice a pattern for graphs as well, just like slope. So now we're going to be moving on to the incredible shrinking dollar. So what's going to happen here is I want you to jot down anything that you notice in the video. Anything you notice at all. So I'm going to start the video here. So that was our buddy there. He was shrinking $1. So I want you to take some time and answer these questions. What is Dan shrinking the dollar by each time? As we saw in the video, he was actually shrinking the dollar 75% each time. So I want you to pause the video and I want you to figure out if Dan shrinks the dollar 9 times, how big will it be? To create a table to definitely help. Remember, you need to figure out what the height and the width of the dollar will be. So go ahead, answer questions 2 and 3, and we will work together on solving them. So now that you've taken a couple minutes and solved what it should be, let's look. I would suggest of making a table. So if I was going to make a table, my x would be shrink, and I would have my height and my width there. So I'm shrinking it all the way to 9 times. What the heck is going on? There we go. All right. So I'm going to shrink it 9 times. All right, so I know my height, my original height before I shrank it was 66 millimeters. And the width is 156. Oops. Now, each time that we were changing, Dan was changing the height and width, it was changing and shrinking by 75%. Now 75% as a decimal is going to be 0.75. So for each of these, I'm going to multiply by 0.75 all the way down. So now that you have that bit of information, keep multiplying each of these answers by 0.75. So if I took 66 and multiplied it by 0.75, I would get 49.5. And if I multiplied that again, I would get 37.125, and continuing on. Same thing with 156 times 0.75. I would get 117. And if I multiply it again, I would get 87.75. So what I want you to do is keep going all the way down to 9, or if you already found your answer, sweet. Let's see if your answer is the same as creating a table. So your table should look something like this. Feel free to pause the video and see if you got all the same numbers. So obviously, if we continued on and on and on, it would be kind of hard to see without an equation, right? So do you think you'll be able to see it at that small of a millimeter? Go ahead and feel free to answer that openly, or write it out, or type it out. Now that you've done so, let's look back at our video. So here is what happened. So there's our original dollar. So it keeps shrinking. So there's our first, our second, third, and it just keeps shrinking every time by 0.75. So it gets kind of super duper tiny. But what's happening is we can still see it. We can still make copies of this dollar. And even though it's super tiny, like maybe doll-sized dollars, we can still see it with our eyes. We can still see and compare. So if we were going to actually graph it or see what type of equation it would be, our equation would be this. Y equals 66, which is our original height of our dollar, times 0.75 to the power of x, because it is reducing by 25% each time Dan photocopies it. Which, not technically illegal per se. If he was selling the dollars, it would be 100%, and you could definitely tell that it was photocopied. But our height would be this equation. Now, for our width, it would be exactly the same, except our width was 156 millimeters wide, and it would still be times by 0.75 because we're still we're shrinking our amount by 75%. So as you can see, the orange dot here is going to be the width, the green dot is going to be the height. So the last thing that you'll need to do today is to go on Summit and take just the diagnostic of patterns and sequence. Tomorrow we'll actually be taking the PFA in class. Remember, if you have any questions or concerns, don't feel afraid. Make sure you reach out. Have a great day, guys.